Hello, today we're talking about the vertex form of a quadratic equation. And so what that vertex form looks like is y equals a times the quantity x minus h squared plus k. And like yesterday, we are going to investigate in Desmos what the values of a, h, and k are doing. Okay, okay. I'm going to create sliders for all of these values. A, like the other two forms, is your stretch factor. So it is nice that we have the same variable and it's really kind of in the same location for all three forms that identify what that stretch factor is. So as A gets larger, your graph will get skinnier. If A is between 0 and 1, your graph will get wider. And then if A is negative, it reflects your graph and you have a downward facing parabola. Okay, what does H do? Let's try. Oh, that's interesting. So H is literally just like a horizontal shift factor. Yeah. Okay, so what would it be? H equals 4. It appears like the x value is 4 for that parabola. So x equals h. There's our axis of symmetry. Okay, so the h value, this is pretty handy. The h value tells you the axis of symmetry, and it also tells you the x value for your vertex. Be careful about that negative, however. This is kind of like with that point slope form that we did last chapter. This would read as x minus 3.1 quantity squared, but the h value is actually a positive 3.1. So the sign in the equation is opposite the value on the graph. So that's an important thing to think about here. K. K will just vertically shift your graph up and down. So it will affect, it appears like the intercepts, the x-intercepts, and as well as the y-intercept. But K is really just kind of something that shifts your graph up and down. Okay, something also that's important to note is K equals 2, is the y value for your vertex. So hopefully you're identifying why this is called vertex form. The h is the x value for the vertex, and the k is the y value for your vertex. Easy enough. Okay, and then a is your stretch factor. Okay. Let's take some notes on vertex form. So vertex form looks like y equals a times the quantity x minus h squared plus k. And as we saw in Desmos, the axis of symmetry is just x equals h. It is important to note, though, that h is the opposite sign in the equation. So if that's helpful for you to remember, in the equation it reads as minus h, and the actual x value is just h. Okay, the vertex. This is the easiest one to find. Okay, on our graph, that vertex is literally just the ordered pair h comma k. So no calculations needed. You can just identify the two values from the form. Miscellaneous, the vertex form will tell you the concavity. So once again, based on that a value, if a is positive, it's an open up parabola with a minimum, and if a is negative, then it's going to be an open down parabola that has a maximum. Okay. This form will also give the vertex. All right, graphing in vertex form. Is our random parabola. What we're going to do as far as our steps is obviously start with the vertex, h comma k. So we're going to plot the vertex. And then from here we want to use the stretch factor to find 2 more points. We talked about this earlier this week, but from that vertex, no matter where that vertex is located, if you go right by 1, how much you go up is that a value. So if you had an a value of 2, you could go right 1 up 2, and then by symmetry, you could go left 1 up 2 and find a point. If your a was negative, it would tell you right 1 and then down by however much your a value is. So the a value is helpful in finding a few additional points on either sides of your graph. Okay, let's do some practice of graphing vertex form. The first one that we'll do is y equals negative quantity x minus 2 squared plus 4. Let's start with identifying the vertex. The vertex would be 2, 4. Notice that I've changed the sign, so it was x minus the h value, so h is just 2. So I'm going to plot the vertex, right 2, up 4. And now I'm going to use symmetry and the a value to find 2 more points. Okay. Our a value is negative 1. So that tells me from that vertex, I'm going to go right 1 and then down 1. And then I can do left 1, down 1. I can find a few more. I can go right 2, and on our original graph, it would have been right 2, up 4, if it was just on like the parent function. But this one, since it's negative 1, is right 2, down 4. Hey, check that out. That's getting us our intercepts. Left 2, down 4. And if we really wanted to, we could go right 3, down 9, and left 3, down 9 as well. Kind of missed the origin there. Oopsies. Okay, so there would be our graph. We could plot our axis of symmetry, which is the line x equals 2. That's it for that example. Let's do one more. Y equals 3x squared minus 1. This equation can be thought of in 2 different forms. It could be standard form, ax squared plus bx plus c, where b is 0. Or it can be in standard form, where it's quantity x minus 0 squared minus 1. So you can plot this one a few different ways. If we're using vertex form, the vertex would be 0, negative 1. The 0 is coming from the fact that this is really like 3 times x minus 0 squared minus 1. So 0, negative 1 gives us the vertex, and it's also giving us the y-intercept. Okay, so that's where it's like the standard form. This plus c is just the y-intercept. By symmetry and our stretch factor, we have our a value of 3. So instead of going right 1 up 1, I'm going to go right 1 up 1, 2, 3, and left 1 up 3. In our parent function, we would have gone right 2 up 4. But because our a value is 3, we're going to multiply that vertical movement by 3. So you can go right 2 up 12, and that would be pretty much off the graph. It would be up here about. Whoop. All right, and we can plot our axis of symmetry. Our axis of symmetry is the line x equals 0. All right, that's it for today. Thanks, guys.